Welcome to all. This is part 1, lecture 23, if I remember. Lecture 23. I am recording in the daytime today. Actually, what happened is, yesterday night I recorded. After uploading, what happened was, there was a term called R into X. See, red color. It is red color value. Where is the red color pen? See, some right time I won't get it. Okay, I won't get it now because I want it now. I see here. See, there's a term called Rx. By chance, I wrote it is not R into X, but I wrote it here. It is not R into X. It is R suffix X. After uploading, I saw it. Then I decided it will be confusing for people. Sir, Rx or Rx, X. Therefore, I decided to record once again. Therefore, usually I upload the class in the afternoon around midday. Now today I am uploading it late. So daytime, so little sound problem, but you can manage. Okay, now we are coming to most critical part, or I will tell the most important part, that is Varignon's theorem. See, respect to Varignon. Color, Varignon's theorem. Varignon's theorem. Make a note here. Note, I will dictate here. One of the most powerful theorems in structural engineering. It is impossible to imagine structural engineering without Varignon's theorem. And entire structural engineering will be standing on Varignon's theorem. It is unimaginable to think of structural engineering without Varignon's theorem. Such a powerful theorem, but so many people are not knowing about it. Very simple theorem. I will tell the statement first only. I will put statement here. Statement I will put black color only. Okay. The algebra, remember now, when we are all discussing everything for coplanar force system. So I told for coplanar force system, actually moment means you take moment about an axis. But if it is coplanar, you can take about a point. So I will take a point. When I tell a point, it is for coplanar. If it is 3D force system, you can apply a theorem, but then moment should be about the axis. We will not worry because 3D manually you can't do. Nowadays software is there. Basic structural knowledge is for 2D. Okay. Now the algebraic sum of moments of a given force system, it can be concurrent, it can be coplanar, or it can be parallel. Outside you can write. For a given force system, about any point, you can write here, given coplanar force system, okay, about any point in the plane, is equal to moment of usual resultant red color always, resultant about, see here it is about any point. You can tell any point about the same point. I read once again. Algebraic sum of moments of a given force system about any point in the plane is equal to moment of resultant about the same point. The most powerful theorem. Okay. This is Varignon's theorem. This theorem we will be using immediately from next class onwards for locating line of action of coplanar force system. Okay, now proof. Make a note first. Proof means you can prove it logically. Without writing anything, we can prove. But if this question comes in examination, if you write that proof, of course there you are right, then they will not give marks. They will tell, no, we do not want your argument. We want mathematical proof. Okay, no problem. Okay, I will first give simply logical proof. I will put in a box, logical proof. Very simple. It is already proved by definition of resultant. Why? See, when you define resultant, what you tell? Resultant for a given force system has the same effect on the body as that of the given force system. Now, algebraic sum of moments of the given force system about any point will give rotational effect about that point. Moment of resultant will also give rotational effect about that point. Therefore, by definition of resultant itself, Varignon's theorem is proved. But people will not accept it. They want mathematical proof. Right? Therefore, what to do? Now we will go for proof. Proof means mathematical proof. Consider a force system. What you have to do? You consider a force system, find algebraic sum of moment of that force system about any random point. Then find moment of the resultant about the same point. Both should be equal. Why? Algebraic sum of moments of the given force system about any point in the plane is equal to moment of resultant about the same point. Okay, I will make ready and start the proof now. Okay, we will start the proof now. So now, proof. Proof for, right here. Proof for what? Already statement over. Right here. Proof for Varignon's theorem. Remember, as I told earlier, logical proof will not hold good. You have to go to mathematical proof, or you can write mathematical proof. Now, one small concept. Varignon's theorem is applicable for any number of concurrent forces. And it is also applicable for general coplanar force system, any number, and also for parallel force system, any number. Therefore, concurrent force system means all forces are passing through one point. There is an advantage there. But if you prove something for concurrent, mathematically it is not valid for coplanar. See why? Coplanar has concurrent extra properties there. Therefore, technically, Varignon's theorem you have to prove for coplanar force system in general. See, coplanar force system in general, this way. But it is almost not possible to prove mathematically because logically I proved. Because so much of complications, trigonometric calculations, and one more problem. When you prove Varignon's theorem, line of action of resultant you have to mark. That is not known. Why? Theorem only will give it. So therefore, nobody will prove it for coplanar force system. This I told earlier in that brain teaser class. Coplanar force system. What people will do is, everywhere throughout the world, they will prove Varignon's theorem only for two concurrent forces. That's all. Say P1, P2. And then, that's all. They will prove that two forces they will consider concurrent, P1, P2, mark the resultant. They will show that moment of P1 plus moment of P2 about any point equal to moment of resultant. They will tell Varignon's theorem is proved. Actually not correct. But proving for coplanar force system, strictly speaking, even I don't know how to prove it. Why? I never thought it. Because I got I got extra information with me, or extra concept I got. So correct, or you can do one thing. You can prove for concurrent forces with only two forces. But then you have to prove that it is applicable for any number of concurrent force system, and also a coplanar force system in general, and also for parallel force system. Okay. Like I told earlier. Once again I will tell. Our country, India, I belong to the state Karnataka. Therefore, if Karnataka state government passes a law, it is applicable only for Karnataka state. It cannot be implemented for the entire country. So if you want to implement for entire country, the law should be passed by the central government, that is central government of India. Then if a law is passed by central government of India, it is applicable for the entire country, including Karnataka, because Karnataka belongs to India, but India does not belong to Karnataka. Therefore, what you have to do is, for applicability for entire nation, central government should prove it. This I told. But still, in this Varignon's theorem, because of some reason, even if you see, it is true everywhere, but here not that way. If the law is passed by Karnataka, I will prove that it is applicable to India. How means later. Therefore, somewhat looks very odd actually. Okay, no problem. That is what everybody will do. See, everybody will do same way. Proof required, simple proof. So we will prove the theorem for, right here, we will prove the Varignon's theorem for only two concurrent forces. And then we can extend it to any number of coplanar force system, or any number of concurrent force system, or any number of coplanar force system in general, and also parallel force system. This is actually brain teaser question number 1 asked by me. See there, I still am waiting answer. I already uploaded some 2-3 brain teasers. Some are giving answer, all wrong answers. So in due time, I will give answer. So therefore, you can make a note here of writing all these. The validity for general coplanar and parallel force system, go through the answer given by him later for question number 1. Okay. So right now, our duty is to only to prove two concurrent force systems. So concurrent force system with only two forces. Right here. Let us prove I want to write Varignon's theorem considering two concurrent forces. Right. Let P1 and P2 be two concurrent forces passing through a point O. I am not writing because feeling little tired. I am dictating. You write or refer the notes. Okay, over. Next, let R be resultant force. Force as shown. You should show a sketch here. As shown. Okay. Now I will rub this one. Space problem is there. Don't see this side. This is the concluding part. Don't see there. Okay. Now mark two forces. See. Consider a point here. O. I forgot, right? I think. Consider two forces P1 and P2. I forgot. Right? Passing through a point O. If I am not told, write it. Passing through a point O. See. Any point O here. See. One force here, P1. Another force here, P2. Theta, zeta not required. No. For this one, same point O. This is your P1. This is your P2. P2 not required. This is your resultant R. Now we have to prove that moment of P1 plus moment of P2 about any point in the plane equal to moment of the resultant about the same point. Okay, now what we will do is, now for P1, P2, some axis you require. I will consider now. See, I will write here. I will write one more sketch here. Where I should write? This I will remove. No problem. See. Now, see here. This is your P1. This is board. Okay. This is your, little this side. Okay. This is your P2. to the point O, right here, through the point O, consider axes OX and OY. OX this way, see, X, and OY this way. OY this way. Okay, now, see here, resultant also is there, OX and OY. Further you have to write one more thing. Consider, I think I need, big sketch is there, no problem. Big sketch is there. Consider any point, say O dash, along OY, at H from OX as shown. You take any point here, say O dash, let the height be equal to H. Now we will prove Varignon's theorem considering moment about O dash, or O dash is our point with respect to which we are proving Varignon's theorem. Or therefore, I will write here now what you have to prove. I will write here. See, finally, therefore, we have to prove that algebraic sum of moments of P1 and P2 about O dash, say we will call it as sigma m about O dash considering P1 and P2 is equal to moment of resultant R about O dash. Say some symbol, no sigma, m moment of resultant R, I should write here, moment about O dash of resultant R. This you have to prove. Okay. If I prove that algebraic sum of moment of P1 and P2 about O dash is equal to moment of resultant about the same point, Varignon's theorem is proved considering two concurrent forces. Now, some student long back asked me, sir, you told any point, no? Yes, correct. Sir, you took a point along the vertical line. You used extra property. Sir, can you take somewhere else? Where? Come and tell me here. Then he told, okay, sir, leave it. Why? Come here, don't hesitate. Come here and tell. He came. He marked P1 not like me. He was not knowing how to hold the pen. You know how they will write. P1 he will mark here. He will mark P2 here. Then he told, sir, you took the point here, no? Somewhere here, sir. Randomly. O dash you take. Okay, I will told, no problem. Then I told him, do you think I am not knowing all this, son? Okay, no problem. I will do one thing now. This point you want to prove? No? Okay. Consider an axis here, y, and a perpendicular axis here, x here. Mutually perpendicular. You consider one axis to this point, passing through O, and this, you tilt these two this way. Tilt. This will remain same. See, I told, if you want here, tilt. If you want further here, tilt. Will it affect the answer? No, sir, because P1, P2, you are not changing. Then he told, got it, sir. Yes, clear. Then I told him, do you know why I took about this point? If I take a point here, you can prove the theorem. Don't think theorem cannot be proved. But trigonometric calculations will become complicated. Some when you draw perpendicular here, some extra point you have to mark, intercept all you have to consider. Therefore, it will lead to complication. Do you want it? No, sir. No, sir. Okay. Therefore, by taking any point here, it is a random point. Sorry. This is not H. Sorry. This is not H. This is Y. Ayo. I told H, I think there. I think I took it as y. Sorry, what you do is, in the previous statement, one small correction. I don't know. H is something else. See, I forgot. H is something else. Consider any, go back and correct it. Consider any point O dash which is at a height of not H, Y from O. Oh, sorry. Therefore, see, this is not technical mistake. I can still take H, but I took one more H here. I forgot. Usually height you take H. Though at that time I told H. No, it is Y. Because I continued with Y. Some height Y. Okay, change it. Okay, over. Now, this proof point you have to prove. See, what to do. Correctly see the proof. Very simple proof. This I will remove now. I will remove this one. Okay, now. One small construction required. See. Now right here. Let theta 1, see, for force P1 theta 1 be angle made by P1 with OX. See, theta 1. Let theta 2 be angle made by P2 with OX. See, P2 here. I will put here now. P2. Theta 2. See, now, in between, mark the resultant. One more sketch right here. Let, see, for P1 theta 1, for P2 theta 2, for resultant no suffix. Let theta be angle made by resultant with OX. With OX. So, therefore, do one thing here. Here, mark the resultant. Resultant or this angle is theta. If confusion is there, see here, neat sketch. For P1, see here, angle theta 1. For P2, angle theta 2. For resultant or red color, angle is theta. Okay. This one you are right first. Then, one statement you are right. From the point O dash, see, we want moment about the point O dash. No resolution now. From the point O dash, drop perpendicular H1 to line of action of P1, comma, perpendicular H2 to line of action of P2 and perpendicular H to line of action of resultant R. See here. That I will write here later. Draw perpendicular H. Okay, now you have to go to a big sketch. A big sketch for more clarity. See here. I marked P1 here. I marked P2 here. In between I marked resultant R. My O dash is here. From O dash, see here, I marked a perpendicular to P1. This perpendicular is H1. From O dash, I marked perpendicular to P2. It is H2. From same O dash, I marked perpendicular to resultant H. Okay. Now, one important concept. Actually not required. We want the angle made at O dash. See, this is for this force perpendicular H1, angle is theta 1, perpendicular H2, angle is theta 2, perpendicular H, red color, angle is theta. Why? Those who want clear means no problem, or right here. There is a mathematical rule. What? If a inclined line makes an angle with horizontal, any angle with horizontal, then its perpendicular will make same angle with vertical. That means if there is an inclined line here with horizontal, if it makes 30 degrees, the perpendicular will make same 30 degree, not with horizontal, with vertical. Make a note. If a line makes an angle of any angle with horizontal inclined line, then its perpendicular will make the same angle with vertical. See here. P1 makes angle theta 1 with horizontal, this is perpendicular, it will make same theta 1 with vertical. P2 makes angle theta 2 with horizontal, its perpendicular makes same angle theta 2 with vertical. Resultant R makes angle theta with horizontal, this is perpendicular, makes angle theta with vertical. It is quite simple. Okay, now one small trigonometric calculation theorem is ready for proof. I will remove all this one now. See, I will remove this one now. Now right here, see, remember this one. I will tell later, this already told. Okay, this is what you have to prove. See, this is to be proved. Okay, start now. What you do is, see, one small note you write here. Let the perpendicular H1 meet at a point A, this P1. Let the perpendicular H2 meet at B. Let the perpendicular H meet at C. You consider the triangle, right angle triangle, O dash, O and A. O dash, O, A, which is right angle triangle. See here. O dash, O, A, 90 degrees here. See, this triangle, right here. This is your O dash. If you come vertically down, this is the point O. And then your A point is somewhere here. Actually, this is a perpendicular. See, this is your point A. See here. O dash, O, A. This is your H1. This angle is theta 1. Okay, this is 90 degrees. Now, use cos theta. Cos theta equal to, see, this is the right angle. See, this 90 degrees here. For this angle, cos theta equal to H1 by, you know this height is Y. See here, that height is Y. This height is Y. So, it is H1 by Y. Therefore, your H1 equal to Y into cos theta. Very powerful. Okay. Now, don't waste time. Same way, if you consider triangle O dash O B, why you waste one time? Replace H1 by H, cos theta 1. See, cos theta 1. Okay, cos theta 1. Now, if you replace what? H1 by H2, theta 1 by theta 2, you get the answer. You can write here similarly. Don't waste time. Similarly, see. Same, actually not required. H2 equal to Y into cos theta 2. And also, without suffix H, red color H, resultant, that is equal to same Y into cos of theta. You write similarly, or do one thing, draw another two more triangles and waste the time. So all will tell, replace H1 by H2, theta 1 by theta 2. To get H, replace H1 by H and theta 1 by theta. That's all. This is result. So this result you require. Now I am rubbing the board. When I go to next part, this sketch will be still there. And this result I will write here. I will write here now. Why? We already got, it will be written here. So that we can continue and prove the Varignon's theorem. Okay. Now, last part of today's class, I will make it ready. Okay. We will continue now. See, this all over, already explained. Just before I already wrote to save the time. Now remember, just now we got, I made a reminder here because I rubbed it. H1 equal to Y cos theta 1. H2 equal to Y cos theta 2. And H equal to Y cos theta. Just now we got it. Okay, continue. But don't write. Why? Because here I wrote because I rubbed the previous portion. Otherwise it is there. Okay, now start. What you want to prove? We want to prove moment of P1 about O dash, because we are verifying the theorem with respect to point O dash. moment of P1 about O dash plus moment of P2, the arrow mark is missing here, moment of P2 about O dash equal to moment of R about O dash. You can see here all are anti-clockwise. So no sign required. You take anti-clockwise moment. Consider all moments in anti-clockwise direction. Start. One by one. Moment of P1 about O dash. Basic definition. Force into perpendicular distance. P1 into H1. Next. Moment of P2 about O dash. P2 into H2. Okay, now do one thing. We got how much? Moment of P1 about O dash equal to P1 into H1. But H1 equal to Y cos theta 1. Substitute. H1 equal to Y cos theta 1 or equal to, you do one thing, put Y outside. P1 into cos theta 1 into Y. Actually, it is very simple because you don't require. Think a little. See, if the force is P1, its horizontal component is P cos theta 1. If I take moment about this point, horizontal component P cos theta 1 into Y. Vertical component is P sin theta 1 is 0 because why? See, if you resolve here, horizontal component will come this way, vertical will come this way. That only will tell the answer. Okay, leave it. P1 cos theta 1 into Y. Same way, P2 H2 equal to P2 into Y cos theta 2, P2 cos theta 2 into Y. Therefore, algebraic sum of moments of P1 and P2 about O dash equal to, say, sigma m, this we already wrote earlier, sigma m about O dash for P1 and P2, considering both P1 and P2 to understand, equal to P1 cos theta 1y plus P2 cos theta 2y or equal to P1 cos theta 1 plus P2 cos theta 2 into outside y. Now, think a little. What is P1 cos theta 1? Without seeing there. See, force P1. This angle is theta 1. So, you know by resolution, P1 cos, see, force P1 is making angle of theta 1 with the x-axis. So, P1 cos theta 1 is component of P1 along OX. What we will do is, we will write, say, P1x. See, P1 into cos theta 1 is x component of P1. So, P1 suffix x. Same way, P2 cos theta 2 is x component of force P2, P2x. Therefore, now your sigma m O dash for P1 and P2 will become P1 cos, here, P1 cos theta 1 is P1 x suffix x plus P2 suffix x into y. Let it be equation number 1. Okay, leave it now. Now consider moment of resultant about O dash, red color, equal to resultant R into H. M about, no sigma y, only one resultant. M O dash of R equal to R into H. But you know H equal to Y cos theta. Red color is for resultant. R into Y cos theta equal to, once again same as this one, R cos theta into Y. Now think a little. P1 cos theta 1 is X component of P1. P1 suffix X. P2 cos theta 2 is X component of P2. We took P2 suffix X. Now, R cos theta is X component of resultant R. So, R cos theta is component of R along OX. Say R suffix X. That is X component of R. Therefore, sigma m about O dash for resultant equal to, see, R cos theta is R X component of R into Y. Let it be equation number 2. Okay, now I will close it now. Almost over. See correctly. Where shall I write it now? Now this sketch is, no, leave it now. Okay, I will maintain only what is required. Up to here clear. Okay, or 1 minute here. Moment of this also not required. See, which all not required. Sorry. Up to here not required. I will write here now. Up to here not required. Continue. Last closing part. Continue. Right. Now, we know that what? P1x plus P2x, that is what? That is algebraic sum of components of P1 and P2 that is the given force system along OX is equal to resultant Rx, that is component of resultant along OX. In the bracket, right? How by principle of resolution. This is already over earlier. You can make a note. If you want, write once again statement. Algebraic sum of components of a given force system along any axis is equal to component of resultant along the same axis. See, algebraic sum of the components along any axis OX equal to component of resultant about the same axis. Therefore, what will happen now? Therefore, you see here now, your sigma m, no sigma here, moment m about O dash of resultant, which is originally equal to, that is from equation number 2, which is equal to what? Rx into y equal to, you can replace Rx by what? P1x plus P2x into y. Oh, see here, P1x plus P2x into y, that is equal to what? Equal to sigma m about O dash for P1 and P2 from 1 over. Therefore, finally you got algebraic sum of moment of resultant about O dash equal to, no algebraic sum. For resultant there is no algebraic sum, sorry. Moment of the resultant, what algebraic sum? Moment of the resultant about O dash equal to algebraic sum of moment of the components or of the given force system about O dash, right here. Therefore, lastly right here, therefore what you can tell? Sigma m about O dash considering P1 and P2 is equal to, now not required, equal to m about O dash for resultant R, or algebraic sum of moment of the given force system about any point, say that is O dash, equal to moment of resultant about the same point. Therefore, right here, Varignon's theorem is proved considering two concurrent forces. That's all sufficient for us. Now, how it is applicable for any number of concurrent forces or a general system of coplanar force system or what? For a parallel force system, usually nobody will do. They will stop here and tell Varignon's theorem is proved. But technically, you should consider it. That I will give answer in the brain teaser part. I told already, there I will explain all those things. Okay, now, class over. It's over now. Next class, we are considering resultant for a coplanar force system, most important, where you have to locate a line of action, you have to locate, you have to find magnitude like concurrent, direction like concurrent, that's all in concurrent. But here extra is there, locating line of action for which you require Varignon's theorem. Okay, thank you. We'll meet you in the next class.